All right, hello everyone. So today is going to be week 3 programming training. Sorry for the video being taking so long to be released, but hopefully this third one, fourth, fifth, and even the sixth one will be all released pretty quickly. And so let's go ahead and get started. So this is just a brief overview about our team again. So Wolf Robotics, that's the team I'm on, and this is will be the people hosting this 6-week training, and not only for our own team, but we'll be releasing content out to you guys. And always feel free to contact us if you have any questions. So the training overview is, once again, to give a high-level overview and fundamental technical knowledge in Java and FTC robot programming. No experience is needed. And so we'll be on week 3. That will be using the FTC SDK and running your first autonomous. We'll do a quick recap on week 2, the Java crash course. And so basically, we talked about how Java worked, programming language itself and syntax, and not necessarily anything that was related to FTC programming, mostly focused just on how to write programs and the syntax and semantics on running Java code. If you have any questions or look back onto it, we also have that week 2 video here, and I also suggested a pretty good resource as well for further learning, and that was the New Boston beginner tutorial. He also actually has an intermediate tutorial, but based off what we're learning today and just the progress we're trying to get, it's not really necessary. But some of the information and lectures, talks, and labs he has is pretty good. You can learn a lot. You can definitely apply it to FTC program. And so today we'll be doing kind of more on just getting hands-on and starting to actually build visual or results that you can see on with your robot moving. And so first we'll talk about the FTC SDK and the contents of it. So what the FTC SDK is a comprehensive library that gives us the tools that we need to program a robot. And you can imagine if with just the bare Java syntax, maybe just only the Java bare libraries, the util libraries, you can't really communicate with a robot that's been, manufactured by a company. Communicating to the control hub can be very difficult. So what the FTC SDK library does is it gives us a means of communication to how to program the robot and control motors, servos, even things like LEDs. And so FTC SDK is basically just some code and some already set up frameworks and libraries that, or it's just this interface that allows us to use control the robot. All right, so they also have a lot of sample code. So if you follow along the previous videos, looked at our Android Studio, you can tell how they have a lot of sample code. So by the way, this is when you open up your FTC Android or your robot controller. Make sure if you're opening it from here, you're clicking, there might be another one here, there might be a lot. You want to make sure to click FTC robot controller -master, wherever it's called. So you can see the same for your Frenzy repository. Our team's working on the same kind of structure on the top. So it's the one I'm in right now. And if you open up Java, external samples, here's all the samples. A quick note, if you don't actually open the top folder, you might have some issues where maybe this doesn't look the same, your team code might be inside your robot controller, some other issues. But if you do have it open up correctly, you can see all these samples. And a lot of these samples are really helpful for getting started programming and just generally useful as a beginner. And so we do have these samples, and actually we'll be taking on these samples today, the FTC drive-by or the push-bot auto drive-by time. But something that's even more comprehensive than sample code is actually the Java docs they have posted on tech.github.io. And so you can take a look and see how there's literally everything inside here that you could probably ever think of. So for example, one thing we could take a look into is, let's say, a gyroscope. And this gyroscope allows us to actually, later on, we'll be talking about it, even in this program, like getting angular velocity, and that could be particularly useful. You could also extract position data, and when you know what angle you're headed turned towards, especially in your yaw motion, that could be really useful for turning and stuff like that. We can take a look at another one and talk all about it here. Actually, let's go ahead and take a look at DC motor X. Look at DC motor X, read about it. So DC motor X basically provides enhanced motor functionality, which is available with some hardware. And talks about how it's a second interface on an object whose primary interface is the DC motor. Access it, cast a DC motor object to DC motor. And so you can see some PID coefficients. You guys know what that is. But this is particularly useful for setting velocity and setting some more complicated things than just a regular motor. And a lot of this might seem pretty daunting at first, but don't worry. Just kind of take it slow, and I think you'll learn it, and making sure just to read through this. And it's always like kind of a process of learning all of this. It's not going to be instant, so don't be too worried about it. So some of these are kind of intuitive, actually. So for example, you can check if the robot motor is busy. That could be pretty useful. We'll actually be using that later as well. Setting the target position, drive to, setting zero power behavior. That's actually something our team only learned maybe a couple years ago, where it's actually really useful because if you can imagine, and this is actually, we found it in the docs. You can imagine if you have a robot that's kind of just hovering, right? Let's say, usually when you're moving on the ground, if you kind of move from point A to point B, and you can just stop at point B, and it doesn't really matter that what your zero power behavior is, because you got to point B, and you push over the motor, would kind of just push over, and that's all right. It might have a little bit of fluctuation, but that's okay. As long as no one's like kicking your robot or anything. But you can imagine for maybe something that where you're fighting against gravity or this constant force. So in the previous years, I think Rover Ruckus, there was there's part of the competition was to climb onto this lander thing and hang from this hook. You can imagine if you had a zero power behavior of just default, where once you reach your position, you just set the power to zero and that's it. Your robot's gonna fall from the hanging position because gravity's pulling it down. And so something useful that we found, we change the zero power behavior and click on it, and bring us down here, and you can see how it takes a zero power behavior on that, and then so the default is floats. So an external force attempting to turn this motor is not that active resistance. So from the lander, the robot would just fall. But with something like brake, it resists the force. And so the really neat thing is you can keep your robot hanging in that certain position, and that'd be really helpful. And yeah, so a lot of this you can kind of might be irrelevant to what you do, but you can always refer to here if you need some more clarification on what some certain functionality or part does. All right, and a side note on readmes are also particularly helpful. And as you can imagine, readmes, what you do is you read them, and they're usually in the file extension MD, which is Markdown, and Markdown can make a readme nicer to look at. So you might see some, you can maybe even search up example of readme. And make a readme. So yeah, readme is a text file that introduces and explains the project. Why should I make it? Easy to answer questions. So you can make a README for your controller and for your project, your robot that you're writing about. You can write READMEs about the programs you have in it and what they all do. And that'd be really helpful for not only programmers, other programmers in your team or outside of your team looking at your code, but also maybe just some team members that are not as experienced in programming, but if they read the README, they maybe will be able to grasp some idea of what the robot does. So let's go ahead and continue on. So this is that was just more the lecture. We're talking about FTC SDK and kind of some of the contents and resources. Now we'll be moving on to actually writing teleops, and autonomous. And for this video today, I think we're only going to be writing an autonomous. So let's go ahead and writing. But autonomous actually won't be the only file we're writing. We'll also be writing our hardware push file, as you can see down here. So first off, we have the overall process of programming the robots, just the general outline of what you should be doing before you're actually even writing the hardware push button autonomous to ensure that your hardware push button autonomous works well, or your robot overall works well. And so the first level is actually ground level robot hardware. So you want to ensure that you're double checking everything that you do. So whether that's motors, servos, encoders, or wiring, you want to make sure that nothing's messed up at hardware level. Because if you have something wired incorrectly or faulty motor or faulty servo, that's going to really mess with when you're trying to program it. And so there's some ways to obviously test this. For wiring, that's pretty easy. Just make sure that everything's connected. There's nothing loose. When you're connected to encoders, when we later do encoders or when you're doing encoders, making sure that encoders are plugged the right way in, not only in for connecting the control hub, you really can't plug it in incorrectly or connecting to expansion, but the motor encode, there's probably this little conversion like piece of electronic that you have to use to connect the wires. I think it's motor electronic encoder. Oh, this is actually, talking about this website. This is the Rev Robotics documentation is also a pretty good resource for learning about how encoders work, things like that. Oh, we won't be going into that right now. That's probably out of scope for today's lecture. Lab. Let me see if I can find it. Oh, yeah. So here it is. So you can see how so this is probably the wire that comes out of your motor. You're gonna have to connect it to this middle piece right here. And you're gonna connect it to this red, blue, black, white wire that goes into your control hub spectrum. But you want to make sure the black is always wired correctly. So black goes to ground on the part. Okay, enough for sidetracking. But yeah, making sure everything's wired, set up correctly. And for motors, servos, there's ways to test them that we'll probably go over actually for easy ways to test them, make sure everything's correct. And then after you have all the hardware done, there's also the control hub set up. So if we can go back to the Rev Robotics, just where we were. This talks about the control hub. It kind of sucks. Actually, we had the robot actual set up a couple of days ago or a while ago, and then the robot's currently getting fixed. So if you guys have any questions, you can feel free to contact our team. But I really can't do a live demo. Sorry about that. But for the control hub, it's mostly just powering on and also connecting to the Wi-Fi and being able to download that. And I'll talk a bit about that for download programs. But you can just around and also ensuring that your firmware is updated. And this is what kind of the dashboard looks like that we talk about here, the robot dashboard. But making sure it's not too difficult. You can just follow through here, and really can just click through any resources. It'll probably help you out. They give you some specs about. Well, it's really unnecessary, but because most things within the FTC world are all kind of compliant with each other, it's always good to have this documentation out here. And so that's the control hub, the driver station setup. This is the app that we use to connect to the robot and run programs on the robot, and also where your robot configuration will be. You click the 3 dots and probably like a configure robot option. There'll be some steps to create a new setup, and you can probably also Google that, and you'll probably hopefully see your control hub connected, and you'll be able to scan and set your robot up that way. Also, this driver station phone, which this app will be downloaded on a phone, will have to be connected to the same Wi-Fi as your control hub, or if you have a robot controller, same idea. The robot controller app actually will go ahead and I doubt that many people use it anymore, but the robot controller is another app by First, and this is for putting onto your robot as alternative for the control hub. They both perform around the same task. And so yes, driver station is also where you configure your robot. And when I mean configure a robot, I'm saying, I mean telling which names of which motors are in certain ports, and we'll talk about that more when we're writing our push bot. And then finally, we have viewing our dashboard. I also don't have a picture of the dashboard. I don't have a live connection, but you can just see. You can probably, I think it was here, right? So you can kind of see what it looks like. So here is your program manager. Go through here to edit your Wi-Fi settings and updating your firmware is also. So I think firmware, you can also check it out. And finally, we have so robot configuration, robot dashboard. The configuration is linked to driver station. Dashboard is viewable through this address. Excuse me, sorry. Viewable through this address when you have your computer or your device connected to the same Wi-Fi as the control hub. So yeah, that's about it. And now we'll go ahead and jump into the writing the hardware push bot. And so once again, I'm sorry about how we don't actually have a live setup. But if you guys have any questions with your setup, just feel free to contact our team and we'll be glad to help you guys out. So writing our hardware push bot. Let's go ahead and actually, we have some of this. I'm going to go ahead and delete all of this actually. Let me put it on a notepad doc and move it away, just in case I need reference. But we'll go ahead and delete this hardware push bot so you can see actually the file. Cool thing about, well, Linux is a lot easier, but you can still go ahead you can use the command line here on the terminal for Android Studio. You can go, let's go ahead and change your directory to team code. And Java. That's not CD. SRC. CD main. And CD Java. CD org. First and so kind of annoying actually, probably. Oh wait, well, that was kind of a waste. You can actually just click open in terminal. Okay, so if we're in this folder, we can actually just delete /f and then our push bot and then also and there we go. If we open the folder again, you can see it's on gone. Okay, so let's go ahead and set up our hardware push bot first. It's pretty important. So this hardware push bot, if we look in our sample code Java samples, this is so it's not an op mode, but this class can be used to define all the specific hardware for a single robot. This is really good for, since you're running multiple programs that have to always access the same hardware because you have one robot, same hardware. So it's good to centralize all this. So when you have to change one thing, you don't have to go through all your programs and let's say change the name of whatever add to just change it here. And all other op modes can kind of use this file class. Okay, so let's go ahead and make a copy. So you can right click on it, or you can just click on it and Control C, copy, copy. And then we can go over here to our team code and then here and paste it and go ahead and hit OK. So hardware push bot will be made. Important thing is to open up the import and make sure there's no weird imports here. So if you see one that's like a sample, we don't want that. Oh, that's actually not for this. It's probably not going to go for the teleops. Talk about that, or the autonomous and the teleop. And so we can go ahead and delete most of the comments. because it's like a sample code comment, and it's kind of irrelevant, especially this part where we're changing the motors. Let's go ahead and delete the comments, and then let's go ahead. And so for our system that we use, we have actually also, I assume you guys can also follow along and kind of change it based off your system. But we don't have any servos in our system, so I don't think we're really going to be covering servos. We're just going to be covering mostly drivetrain movement, and but servos are kind of similar to motors, but servos in the sense can only go from 180 degrees, but we'll only be focusing on motors. So we actually have a 4-wheel mechanism drive, and that gives us some cool functionalities like sidestepping that we'll be talking about, and basically moving laterally without having, like, let's say if we wanted to go sidestep left, we wouldn't have to we don't have to turn and move forward. We could be able to just keep our heading, and heading's like where you're pointed towards. So let's go ahead and change left drive to left front. Left front as in our left front motor, which will assumedly control our left front wheel. And then change that to right front. Let's go ahead and change this to left back. And you can notice how we use this kind of camel case convention where the first word, first letter lowercase, but every following word, first letter uppercase. And so they also like to tab it, so it kind of looks aesthetically pleasing, if you will. And there we go. So we have all 4 motors set up. And then I'll also probably be attaching this code. So, but I think it's always good to improve your typing skills or something like that. And so here's our hardware map, and here's our elapsed time. The elapsed hardware map is basically from, as you guessed it, you map your hardware. So you say, all right, this are ports to this, and we actually can check out this class. So go to declaration usages, Control B. See how this is a lot of more. It gets closer and closer to hardware level stuff, and less abstract. The abstraction starts going away as you get closer and closer to the actual base control, and eventually to like the hardware level control. And so you can see how there is a lot of methods, and thankfully we don't actually have to worry about most of this. We just have to know what it does and use it. And that's, I guess, a neat part about programming in general, concept of abstraction. And so here's our constructor. We don't really have to do anything for the constructor, but the init is pretty useful. And so I'm just going to make sure. No, okay. Let's go ahead and you see all these errors, and don't worry, we'll be able to change them. So servos, we don't have any of those, so we can delete that. The left arm, we don't have that. So left arm. And now we don't have our left drive, right driving. So we have left front, left back, right front, right back. So we can just go ahead and delete this. Delete one, and we'll copy paste this one more times. Motor. And so this is where you basically tell, all right, we have this variable called left front that represents the DC motor. What is the actual physical representation? And so what happens is in your robot configuration on your driver station app, let's see, this is where you'll be going into 3 dots, creating a configuration of your robot and telling where certain motors are on control hubs, etc. And then they'll basically ask in there, there'll be a box that's port 0, the name of the motor. So for example, you might have your left front motor inside port 0, and then so you're going to go into your configuration, and in the driver station configuration, you're going to say port 0, that device, whatever motor is called there, it's going to be called left front, or LF is what our team do. And so we'll want to put LF in here, that gets the device name. And so now whenever we run left front, set power, set the power, change the position, maybe even set the brake behavior, will be this. That command will point to this left front pointer that points to the actual port and so on. And so the port will actually point to the actual motor, and then set the power, then that actual motor moves, and we're happy people. So let's go ahead and do that. Left, back, right, front, right, back. And so this is all properties of this hardware push bot, which we'll be able to use in their programs. All right, there you go. That's what we like to call ours. RF, RB, it's whatever you guys make it up to, but make sure it's always the same as whatever you put in the configuration. All right, and then you might have to reverse some of your motors. So for regularly, you reverse your left, or for us, depending on what's the front of your robot, you might have to mix it up, but we reverse our left motors. So let's go ahead and do that here. And if you're wondering what the robot we're talking about, we just have a simple, I think, go build a V3 shape kit. Yep, so this is the setup we have. So there's the ability. Oh, there's a version 4 now, so I bet you more people have the version 4. Okay. So now we can do left front dot set. Actually, we want this right front to go forward. And why you might want are asking, why do we need to reverse the motor direction? If you think about it, if you set this right motor to go forward, it rotates like this. And then if you set the left one to go forward, it's going to go the other way because the motor's like flipped on the other side. So you want to reverse it so that when you set power to both of them as one, they'll both be rotating in the same direction. And so right front forward, left front reverse, copy that, add a space, add a comment, reversing left motors, and go ahead and change that right back. All right, setting all motor powers to 0. So let's actually make a method. So we'll leave this blank. We'll talk about why we'll make a method. We'll make a method. And actually, for now, we'll keep it red, but we'll have something called set motor powers 0. And I'll set all the powers to 0. And then set all motors to run without encoders. So let's go ahead. And so if we most likely actually do have encoders, so we can probably do left front dot set mode, right front dot set mode, and then we'll copy this and put left back, right back. And so you actually might notice a lot of this code is redundant. And so we can write methods to do it. For most of this stuff, we might only do it once, but for setting motor powers, we definitely do a lot. So I'll show you guys how to do this. And if you guys are interested in kind of following the same format for these, you can feel free to do so as well. But we're gonna go ahead and write a method inside this public hardware push bot. We're gonna write this a method in this hardware push bot to set all the motor powers to 0. So how you actually let's show the long way first. The long way you do it is you do left front dot set power 0, right front dot set power 0, and you get the idea. Just left back, right back, set power 0. It's 4 lines of code, and another thing to notice, you want to keep your code clean. That's just general good practice. You don't have to have redundant code. So what we're going to do is we're going to write a public method, because maybe other teleops autonomous's will use this, and we'll be able to set the motor powers instead of putting all those 4 lines of code. We just have to write one line that does it all. So first, we're going to want to actually build a more general case. What if we want to set the powers for each motor differently? So we're going to write a method called public void set motor powers. We got to have the same signature as the one I used. And we're going to do double left front power. Or actually, it's just do LF powers. Double RF power, double LB power, double RB power. And what we'll do is we're going to do left front dot set power to LF power, left right front dot set power to RF power, back dot set power to LB power, and finally our right back that set power to RB. And this is a pretty neat method. It will allow us to, and we can write some documentation, sets all motor powers to. And so these documentation, you just do /2 asterisks, and I'll give you this nice green documentation. And so it's different than these gray ones, just comments. There's all motor powers to, but it's kind of similar. The compiler, the Java compiler ignores both. So it's just for human eyes. It says all motor powers to given arguments, speeds. And that's it. And so you might be wondering, well, we only put in one argument. Okay, so this takes 4 arguments. How do we do a one argument method? And the one argument method is a example of method overloading. And so what we're going to do is we're going to create the same name and same public void, but instead what we're going to do is instead of putting 4, because what if someone just wanted to set them all to full speed, or in our case, set them all to 0? So instead, we're going to create a method that just takes in one argument. So let's say all power. And then what we'll do is we'll call the other method that has the same name, but has a different amount of arguments. And this is the concept of Java overloading. And what will happen is we'll just do set motor powers. Oh, we don't want to just set all of them to. And so you can imagine this is a slight improvement, because if we wanted to do it with only this method, we'll have to do 0, 0, 0, 0. But now we can just do 0, and it'll run this method, which we'll call this method, but just with this value as every single value of this method. Pretty neat. So set motor power to 0. And we can also use this in other methods, and go ahead and show you how to do that. So make sure you're doing, by the way, all of this in harder push bot, not the sample code. That would have been pretty bad. Hopefully you can control Z it. Worst comes to worst, you just go online, search up FTC robot controller, you re-download the hardware push bot that was in the sample, and just copy, or make sure to copy wherever you change to here first, and then you re-download this sample code. But that's about it for our hardware push bot. We set up all 4 motors that we'll be using. We wrote a pretty neat method, and let's go ahead and make our first autonomous one. We'll be about done for today. So we can go ahead back to the sample code, and we can click on by time. And we'll be teaching other ways of localization. But we'll do by time, and then we'll copy that. And right-click, copy, or just Control-C here, folder, and then paste it. And this is where you might want to check your import, and you want to get rid of this external sample hardware. So it might be condensed. We open it, get rid of the external samples, because then you're going to be using the hardware push bot from samples, and we want to do that. Then go ahead and delete the documentation, and you can delete the add disabled because we want it to be enabled. Let's see, add disabled, delete that. So we delete the documentation. So we delete the import. So we won't be using the hardware push bot. We delete the documentation because it's not really relevant to the actual code we're writing. You guys definitely should also write documentation as your program becomes maybe something you guys actually use. Even if you don't use it, maybe just write about a little bit. So we can, let's do that actually right now. So we put something like autonomous code for programmer training will move in a square. Okay. So by the way, that's what we'll be doing. We'll be moving in a, actually, we'll probably leave that off for next week. We'll move forward for 5 seconds. And also turn for 3 seconds. Turn 3 seconds. Okay. And so we made some new documentation. We deleted the add disabled. This import, that's grayed out. We can also get rid of that. Actually, you guys might want to disable in the future. And so even if you get rid of the import, you can still type add disabled, and it'll just automatically import that required class. Actually, I'm not a decorator, I guess. And so we can go ahead and delete all of this. So this looks really long. We actually only need hardware push bot, and that will actually use the hardware push bot. We just created it in the same folder. And so we're happy people. Runtime, we'll keep that. come into play later. Forward speed, it's good to always have these constants that you'll be using. So let's do forward speed half, turn speed both fine. And so here is the run op mode. This is where when you press play and you press init, or you press init and you press play, this is what happens. This is what runs. And so we first initialize the hardware map. We add some telemetry data. Telemetry data is going to be the stuff that shows up on the driver station, that little black box right here, down here. And then we wait for the start for the driver to press play. And then we're going to do our stuff. So this is where we're going to delete all the code they had. Right. Actually, we're going to take a look at their code first. So what they do is they set power, they reset the runtime while the runtime is less than 3 seconds. So this runtime object records time. So they set the power of the forward speed of left drive, right drive. Obviously, we don't have those anymore. And so while op mode is active and the runtime is less than 3 seconds, then they're going to go ahead and so for 3 seconds, they're going to go ahead and robot and do some other stuff as well. Eventually, they're going to set the power to 0 and set the position of call 1 and 0. This basically means like completely open or completely closed, depends how you look at it. Completely open, closed. And we'll say it's complete, and then we'll sleep. Sleep just waits for a second, and then the program ends. So let's go ahead and write our own code. So we're just going to move forward for 3 seconds. So you can imagine while. So what we'll do is first we're going to want to set the powers. That's what they did. And then we're going to want to reset the runtime. And then while the runtime is less than, as we put 5 seconds, we're going to wait. We won't have to, you can put telemetry if you want, but we'll just go ahead and just leave that while it's blank. So first we want to do call the handy dandy method we made on our hardware pushbot, and we created a instance of the hardware pushbot called robot, and that's a robot we'll be controlling. So we can do robot, that's set motor powers. And since you're going forward, all your motor speeds will be the same, 0.5, so 0.5. That's it. And then we can go ahead and reset the runtime. Runtime.reset, that sets the runtime back. It's like a stopwatch. Just reset the stopwatch. So while op mode is active, and this is useful because if you wanted to stop the program midway and you didn't have this, then the program wouldn't stop, and that could be potentially disastrous. And that probably also, when you do robot inspection at competition, by the way, you can read about robot inspection on the game manuals, but you probably won't pass robot inspection. So while mode is active and runtime dot milliseconds, so how many milliseconds has passed since the reset, is less than 3 or 5,000. What we're going to do, nothing actually. So you could actually add telemetry, so add data, and the caption would be like moving forward. And I'm pretty sure we still have to add some value. So just leave it blank. And telemetry update to update the actual screen, the little box you're looking at on the driver station. And so after that, we can set the motor powers to 0, stop the motors, and let's also wait a bit before we turn. So we'll sleep for 1,000 milliseconds or 1 second. Then we're going to go ahead and set motor powers to turn now. So they obviously can't be the same because you're turning. So let's do something like 0.5, comma, negative 0.5, 0.5, 0.5. And as you can imagine, this actually, the left motors are going backwards and right forwards, and you're going to be turning to the left. And we can reset the runtime again, and then same idea, while op is active and runtime dot milliseconds is less than 3,000. Oh, let's actually, we didn't use our variables here, turn speed and forward speed. So let's go ahead and forward speed actually. When we're moving forward in the set motor power call to the robot, and then for this, let's do negative turn speed, and then positive positive. And you can imagine this might be tedious. So maybe you don't want to do this. You could also write another method that's called turn left, and the turn left takes, let's say, direction. So maybe you have a Boolean that says is left, and if you set it to true, it'll turn left. Is right, and is right is true, and turn right. And then it'll set based off the Boolean and maybe like if statement, you'll set the turn left or turn right, and we'll simplify this to maybe just a speed is left or is right. But we won't do that. You guys have, maybe if you guys are really curious about it, you guys can contact us and just get a snippet of code. Let's go ahead and put the same telemetry except, or same stuff in the while loop, except change the telemetry to turning right or left. And then finally, when we're done, when the 3 seconds has passed, and runtime.milliseconds, the stopwatch, which has been reset here, but has been waiting and just been updating telemetry until it's been over 3 seconds. We'll continue on the program and set the motor powers to 0. I'll sleep for a second. And then after I sleep, the program will just end. And you can start the program again if you want. And so that's about it for the code, actually. And you can go ahead and connect to your device and download. So I'll just give you a quick demo of how to do that. I don't actually have a device with me, but you can imagine you turn on your control up. You probably have some Wi-Fi here that might say like FTC dash something random letters or whatever you renamed your Wi-Fi to on your control. So someone might have renamed, you might have renamed it on your control dashboard that we were talking about on the slides. So 192.168.43.1 and then colon 8080. And by the way, to access that, you just type in your browser. And so you can go ahead and make sure you're connected to the Wi-Fi here. Should give you no internet because it's kind of just connecting to a controlled, doesn't have internet. And then you would type inside, your terminal, or you can open up command prompt, adb connect 192.168.43.1. That'd be the command. And you can imagine it doesn't work for me, but also when you run adb, if you see here when I ran adb and I hit enter, by the way, to open up your terminal, just go down here. But you see that when I hit adb, all this stuff popped out, but you might have an error that says unrecognized command. And how you would fix that is you would hit home, you go to your type environment variables. Oh, do it again. Environment variables like env, and this will show up. Click on that, this shows up. And you want to go to environment variables down here. And then in your, let's see, I'm pretty sure it's in your path here. Path, yep. So if you go to your user variables for whatever user you're in, you go to click on path, click edit, or just double click. And then you want to create a new one that's percent local app data %/Android/SDK/platform dash. Can't see this. Let's see. Okay, not a notepad. You guys can see it better. But you want to put this inside your environment variable. So just new environment variable. This and make sure to hit OK and OK and OK. And then if you restart your Android Studio or you open up a new command prompt, when you type adb, this should be able to show up. And basically what you did is there's an executable adb file inside that directory that we just put in the path, and that will allow you to run that executable from anywhere instead of having to go inside that folder every single time. So you'd run adb connect 192.168.43.1, and then you'd be able to connect. And then hopefully this devices would show the control hub, and you can press download or press run team code and then download onto the control hub, and then your driver station. It might take a while. You can probably say Gradle build down here running, like launching, install and then launch activity. It might take maybe even a couple minutes on your first download. And then the program would download. You could open up your driver station and run your autonomous, which would hopefully move forward and turn left. And so that is about it for today. And then also, when you want to disconnect, you'll just run ADB disconnect, and it's always good to disconnect before turning off your robot. I guess disconnect. So there's some certain weird cases where, like, let's say your buddy, maybe your builder buddy, had to unplug and install something, so you unplug the control hub. But the problem is you have an ADB disconnect, so ADB might think you're still connected or some weird stuff. So whenever you're maybe even switching a Wi-Fi channel or switching your Wi-Fi because it has no internet, Google question, make sure to always ADB disconnect before doing anything so that none of that happens. And if it does happen, you probably have to just power cycle your robot. Maybe if that doesn't even work, just restarting your computer. So you just do ADB disconnect and disconnect everything, and you'd be happy. And that would be about it. That's how you download your first autonomous, and hopefully it works well. If you guys have any questions or if you see any errors, please let me know. I'll make sure to put a comment in the description. So that's about it. And then, this is a quick diagram on the mechanism drive. You can take a look at it and see how, if you wanted to go in this direction, you'd be only moving these two wheels. If you want to go forward, you'd be pushing all four wheels, moving that. So you can play around with this for sure. And we'll be talking about how to sidestep and move in a square and that kind of stuff next week. So going to the left, going to the right, turning. So moving the left wheels back, wheels forward, left wheels forward, the right wheels back, and so on. So that's about it. Thank you everyone for listening, tuning in. If you guys have any questions, feel free to drop them in the comments or email wolfcorprobotics12525@gmail.com. So thank you everyone. You guys keep on learning. Any questions, please contact us. And I'll see you guys in the next video.